Okay. So, hello everyone. Good evening. Today we have Sreerajan, Director of Engineering, and others, lead product engineer from Rapido, joined us to share how they are using cloud native technologies to manage their infrastructure. And Sreerajan and others, both of them are with Rapido like for more than 5 years now. I think they know each other from ThoughtWorks, if I'm not wrong. I just went through their LinkedIn just before this call to understand more about the speakers, of course. So maybe Sreerajan and others, if you guys can share more details, like how you guys started getting into this platform engineering things, and like then getting into the topic for today. Please, over to you, Sreerajan and others.
You're right. I think you can hear me, right?
Yes, yes.
You're right. I mean, we knew each other from ThoughtWorks. That's right. So you've done your background correct. So just to give a brief, I was working with ThoughtWorks for almost 8 years before Rapido, and post that I joined Rapido. Starting off with the DevOps landscape in Rapido. Over the last 5 years, I worked maybe 2 to 3 years in infrastructure side of things within Rapido, and then currently now I'm working in the marketplace team, which deals with systems that handle pricing and or orders and propagation within Rapido. So that's the role that I'm playing currently within Rapido. Adarsh, you want to give a brief intro?
Yeah. Prior to Rapido, even I was with ThoughtWorks for like 3.5 years. Prior to that, I was with a mix of services and early stage startups. Uh, with in Rapido, up until Rapido, I've been mostly working as a backend developer with a little bit interest in distributed system, but all theoretical, not nothing hands-on. At Rapido, I got that opportunity to work with some of the systems at scale, and Rapido mostly I've been working on the infrastructure area.
Cool.
Okay.
Okay. We'll get into what we want to cover maybe in this session. So before we start, we'll give a brief intro on Rapido. Hopefully, most of you have heard about Rapido. If not, maybe you can hear about us now. So we are a ride-hailing platform, as the slide states. Like you can book a taxi through Rapido. It could be a bike. It could be an auto. There are segments of auto. It could be an auto premium. It could be an auto plus. You can also book a cab. It could be a cab economy or a cab premium. Right? So there are segments of taxis that are available. So you could request for a ride, and your ride would get fulfilled through Rapido. So in a gist, that's what we do. We are currently spread across more than 100 cities in India. I think it's way more than 100 now. Maybe that data is a little outdated. And we are expanding as we speak and at a rapid scale. Um, we will be present in more and more cities in the next 3 to 4 months aggressively, right? So that's the current scale of operations that we have at Rapido. We have been Rapido app was started in around 2015, so we've been around 10 years now. Like mine and others' journey in Rapido starts from 2019. So that's a brief intro of what Rapido does. I can go to the next slide. Um, so I'll give you a brief, a sneak peek in what we are planning to cover. So we will just look at maybe year 2019, 2020, and we'll call out what was our state from a software system perspective, what were the challenges that we were facing, and what did we want to achieve from that space, and what made us think about, okay, we need to be looking at a target state, and what should we be looking for when we imagine that target state, right? So there's something that forced us also to think about that target state. We'll give a brief overview of that. While there are multiple things that we wanted to achieve in target state, we will walk you through maybe a few components in that, which kind of has helped us immensely. maybe the ones which had the most impact for us to handle the scale that we are operating today, right? So many of them helped us in reaching the target state, and on the way, some of the levers those toolings exposed kind of helped us come out of different difficult situations when you actually see scale in the real world. Right? So that is how the gist of the session is going to be. Um, so 2019, considered to the scale that we are, maybe it was 10x lesser at that point in time. Um, I think number of cities might also have been small, lesser compared to what we are today, of course, because we have been expanding in the last 5 years. And like many startups, we also had a bunch of problems. The one that are listed on the slide kind of is self-explanatory, right? Um, Deployments were not automated. It was not a one-click deployment. Uh, People had to manually deploy code into production servers. While one was doing that, there's naturally a problem when we are managing configurations. There is drift of application code also if I'm manually deploying which version of the code is deployed into production server. There's lack of visibility. Only the person who's deploying it knows about it. To give a little bit, view onto it, it was like we had VMs. People had to SSH into the VMs. There'll be a bunch of people with access. They had to SSH into the VMs, clone the code, and compile and execute the code, right? So it was that manual at that point in time. And when I'm doing that, if it is deployed across 3 servers, the configuration is also checked in along with the repo. So it's cloned into 3 places. If I have to change a configuration, I have to get into 3 servers and then change the configuration. And there's no guarantee that this configuration gets back into Git, right? I mean, if someone does it, yes, it gets back into Git. If someone doesn't do it, it might disappear. Next time someone updates the branch and then deploy it, uh, if you're lucky, it might still be okay. If you're not lucky, it might not be okay. Right? So it was all left to chance. So those problems existed. And the infra was also, like I said, it was VMs, and then we were running on VMs. And if servers would be deployed in maybe 3 or 4 VMs, there was an Nginx server in front of that, so which was doing the load balancing. So if I had to scale, we had to create a new VM, clone the code, execute the code, and then add it into the Nginx load balancer, do a hot reload. All these things had to be done manually, right? It's possible to automate it, but then we hadn't automated. Most of these things were manual at that point in time. And some of these Nginx servers were single point of failures. If it goes down, that whole service is unavailable. We also had other uh, points of failures from a database perspective also, right? Like we had Redis clusters which were running on one node. Um, Other point of failures also existed. Security, I'm not going to go into depth. Of course, secret management was a problem, and we were also spread across multiple cloud providers at that point in time. We were on DigitalOcean, part of it. We were on AWS, and we were on Google, mainly Google, but then we had some spread in AWS and DigitalOcean. Right? So we were spread across. Because of that, also posed some amount of security concern. The major problem that we had at that point in time, maybe the most dangerous one, was observability. We could say it was almost zero, right? At that point in time, we had around maybe 70 to 80 microservices running. So if something goes wrong somewhere, like if there's a production issue that is getting reported, it's like, okay, without having an in-depth understanding of the application, like who calls what, which all services comes into interaction when this particular flow is getting if flow is running, without understanding that in depth, having that in depth knowledge, it was very hard for anyone to debug because there's no observability, right? We don't know where the latencies are spiking up. We don't know where the errors are happening. There's some bits of alerts, but maybe not all over the place. Some bits of alerts existed, maybe very, very critical places, but if we go deep into the pipeline, the observability was very minimal, right? And that was a major, major problem. Not like the other problems were not real problems, they were also problems, but observability was, even to do anything about this, we had to have observability. Without that, there's no way to act or change any of this, right? Because we don't know if we're changing, is there something going wrong? We didn't know. So observability was a main problem even to touch this. It was like that broken window. Okay, fine, let's not touch it further. If we touch it further, maybe it's gonna break all over again, right? So observability was a huge problem at that point in time. uh, so all these existed. But having said this, one thing that we need to understand is every organization, like most of the startups, go through a journey, and the initial part of the journey is the 0 to 1 journey, right? So when we are going through that journey, I don't think we can be in a position to say that I'm going to build my system the best possible way. There always has to be a trade-off. It's a give and take, right? We'll have to compromise on certain aspects, and most of these were after effects of that compromises. Uh, we could think that, okay, maybe next time if we go through this journey, maybe the compromises would be different from our perspective. We might compromise a bunch of other things, but maybe we might not compromise on some of the things, like maybe observability is something that we might not compromise in the first cut. But then at that point in time, given the context and everything, the priority was time to market. For that time to market to be achieved, some compromises had to be made with whatever um, ability we had at that point in time. We made these compromises, and we had this. All these were side effects of those compromises, right? Fair. Um, by 2019-20, and every organization which goes through that 0 to 1, at some point in time, the idea becomes viable, and then it gets traction and everything. Then comes, okay, fine, let's scale, right? Let's scale phase comes into picture. That's when many of these kind of becomes problems, and we kind of end up opening the can of worms, and then it becomes a little ugly. Um, so that time, I think, came in somewhere around 2019-20s for us, when we started seeing scale, maybe not the scale that we are operating at now, but then, some amount of scale, which was good enough to maybe knock some of these things out. Uh, which kind of got us through a vicious cycle of, okay, there is a production issue, we don't know what we are supposed to do, because we didn't have observability. We would fix it, but it would take time. The time to react was much higher. And then, because we are not in a position to maybe change it within the next day, because most of these problems related to scale require some time. Next day again, this happens. So we kind of had a lot of disruptions at that point in time, right? We kind of handled using different mechanisms at that point in time, but could have been a lot more efficient, and it became more and more frequent. So that was a time when we realized, okay, there had to be um, considerable amount of changes that we need to put in place, uh, and maybe prioritize them and attack what would be the top priorities that we want to maybe achieve in the next 1 year or so, right? Maybe you can show the next slide, Adarsh. So this is a bunch of them, but this is it's an idealistic state that is very easy to write down. Like, yeah, I mean, we'll remove all the cloud providers. Maybe that's not really idealistic. Maybe one could argue, okay, yeah, it's good to have multiple cloud providers to maybe prevent vendor lock-in, but we wanted to be in one cloud provider for our own reasons. Um, Deployments had to be uber fast, hassle free. Developers should not even worry about it. So from a developer experience, one click, safe deployments. They don't have to worry about whether, even if it's buggy code, they shouldn't really worry about it. They would get feedback, and the feedback would ensure that we are not creating problems in production. Consistent, repeatable one-click deployments. Of course, infra has to be secure. But configuration, centralized configuration was of very importance for us. Um, Observability, paramount importance. Um, Resiliency, which means system should be in a position to auto heal, if possible. Not always we'll be able to auto heal, but whenever there is a possibility, it should be auto healing. And as the scale increases, we don't want to be in a position to sit and manually scale it up. It should be auto scaling wherever possible, right? Maybe databases are not gonna auto scale. Yeah, fine, that's okay. But at least from a stateless perspective, we wanted to ensure that everything should be scalable, resilient, um, with very minimal, as much as minimal manual intervention as possible, um, was the target state that we wanted to achieve. Right. So this was the first slide represented some of the problems that we had. We knew what the target that we wanted to achieve looked like, and on that journey we picked up a bunch of tooling, right? So the rest of the session is going to be about some of those toolings and some of our experiences with those toolings, especially under scale. Some of them really shines, right? So we'll walk through some of them. Good, Adarsh. Yes.
Cool. So, Shri mentioned, we kind of had a target state to reach, and one of the obvious choice, or in retrospective today, which looks quite obvious, is Kubernetes, right? While there are a lot of advantages which are quite evident, like auto scaling, self healing, etc. I'm not going to go into details of those. I want to call out a couple of features which really stood out for us or have helped us. One is the developer experience side of things, right? For example, say we want to scale an application. With the traditional setup that we had to manually do a bunch of things. Even if they are automated, it is not very straightforward to automate them. So instead, what we had was a very seamless way to scale by running a simple command or editing, or basically all we have to do is just mention what is the desired state. Kubernetes will take care of reconciling the live state to the desired state, right? Like again, it's like Kubernetes 101. I'm not going to talk much about that, but developer experience again was made easy because of the community and the set of toolings, the open source toolings from cloud CNCF tool technologies, or other open source tools. Like we are uh, always we go for open source tools wherever available. Very rarely, or we have zero paid or enterprise solutions that we use today. Almost everything is open source tools, and some of them help us with these kind of activities, right? I'll take a couple of real life scenarios as well. There were cases where we had services which handle both API, which is user facing traffic, at the same time doing some kind of computation, which is async processing based on a Kafka topic or something. This was a critical service as well. And one of the problem that we used to face in 2020-21 was whenever this processing, the data processing task happened, API would degrade. So the solution was straightforward to separate them out. Now, with this, it was just hardly half a day's work. Again, because we have deployments and other stuff, so it's just adding one other deployment which handles uh, the processing side of things and ensure your user facing APIs doesn't face a problem. And this pattern, I think we have followed in a couple of other places, wherein the processing bit is a separate deployment, a separate uh, process running, and the API, user facing API is separate. Also, we have cases where we have set up read write separation as well. Similarly, we have one other thing to call out is how easy is it to roll out and roll back changes, right? With deployments, if you're using Kubernetes deployments, how easy it is to uh, basically roll out and roll back changes. Now, we'll go through some of the problems that we've faced, and how we have solved some of them, right? This is something most of us would have seen, like a spike in 500, or increase in latency during some point in time, right? Now, imagine you have 150 plus microservices. How do we pinpoint? Shri mentioned, when we started, it was 80 microservices. Today, we have around 150 plus microservices, and we have different tech stacks as well. We have Java, Golang, Node. Let's say we are building something custom to bring in that observability here, right? We have to implement that in three languages: Java, Golang, Node. Similarly, how do we bring in that visibility, right? So this is more or less a scenario. We have Kong, which is the API gateway that we use today. From there, it goes to Kubernetes via Istio. I'm not added Istio in this particular diagram. Not important here. It will come later. And then from there, it would look more or less like this. Like, it goes to one deployment, it goes to another, that might be fanning out to multiple other, and then there is a database somewhere. If something goes wrong here, the only thing that we initially had was logs at Kong level, or metrics at Kong level, which says this particular API is timing out, or this particular API is started throwing errors. Now, how do you figure out, how do you pinpoint where is that happening? And that is where we were talking about observability. Should, is there something that can give observability out of box? And service mesh was the answer for that. And the service mesh that we picked for this is Istio. So we use Istio today at production, in production, right? And if you look at this, this is some of the metrics that comes out of box with Istio. So here you can see at in one Grafana dashboard, I can understand what is the request volume, what is the success rate, what is the latency, all the inbound traffic related information. Similarly, all the outbound traffic related information. If there is an increase in 5xx or any other status code, right, to which service is it, I can pinpoint that from here. If there is an increase in latency at different percentile, that information is available here. So observability uh, again is something that we got out of box with service mesh. We'll see some other problems and how we solve them. Another problem that we have often faced is degradation in one of the upstream service. It could be an upstream service or a database. This particular graph that I'm showing us in the case of a database. So this case, we get a third party makes a lot of call to us. I am not going into the use case, but a third party make a lot of calls to us that comes via our API gateway through our Ingress system, and finally it lands up in database. Because of some issue at the external vendor or third party side, we started suddenly getting a high amount of requests, which is not expected, and the database was not sized to handle that level of inserts or updates. And this suddenly put a lot of load on the database, and there is and the result of that was my API was started throwing 5xx, right? Now, how do we handle such a case? If we are facing this could happen even during certain rollouts or other unforeseen. There could be a configuration change which went in, which enabled some feature, basically a feature toggle, which could put suddenly load, which we didn't anticipate, right? A lot of these scenarios happen. One of the primary SOP we have to get out of this scenario, right, is to basically load shed, which is to cut traffic. Well, in this case, traffic is coming from outside, we cut traffic, or we could even reduce the amount of traffic. So early 2019-20, how we used to do this is at Kong. Kong is the API gateway, like I said. But we used to face a problem with the version of Kong, or not sure if that is supported today, but whatever version we are running, we are again running open source version of Kong. Only thing it allows us to do is either cut the traffic or allow the traffic. So this is one problem. Something that would have helped us here is cutting maybe a percentage of traffic, right? That is where again Istio to the rescue. With Istio's traffic management capabilities, we can inject fault. What we mean by that is basically Istio itself, the proxy containers itself will start returning 5xx, and we can control the percentage at which we are injecting fault. So we probably would start with 100 percentage fault, or maybe 80 percentage fault, and then we slowly reduce. And this is a common SOP we follow today to get out of situations where there is a unforeseen amount of load on a upstream system. And of course, you can always go and edit the Kubernetes object to increase and decrement, increment and decrement the percentage, etc. But we have an internal tool, Rapido Kotel, that we use, and in that there is a command that is added which makes this whole thing very easy. So one thing is, because we are developers and DevOps people, or whatever you want to call that, we are mostly at terminal. Whatever we do repeatedly, right, it will be always good idea to create CLIs like this. Like Rapido Kutl is a saver for us. A lot of things that we do repeatedly is automated with Rapido Kutl, so that you don't have to go click or do other things, and it's just a command, go run that. It'll be there in your history as well, right? You can always write a patch for this, but this is much easier for everyone to understand and follow. So that said, we'll talk about another problem that we have faced, right? So we have a lot of egress calls that goes out of our system. But I'll take a step back. So the we are on GCP. We are using GK for managed Kubernetes solution. We are using private GK cluster for security reasons. So none of our nodes have public IPs. So obviously, egress traffic would have to go via something like a NAT gateway. Now, some of the problems that we have faced here is one, we have integrations with third-party payment systems, third-party analytical systems, and few other third parties as well. In some cases, we need a static IP. With NAT gateway, the problem is we can't have while we can have static IPs, the number of IPs would be huge, right? At our scale specifically. So to solve this problem, again, we were looking at various solutions, and we also have faced issues with NAT gateways as well. Back then, GCP NAT gateway used to support maximum of 50 IPs, and with our scale, the number of pods, the number of third parties we are talking to, we have hit certain limits, and we were getting packet drops at NAT. There is a blog that we have written about this. I'll share some of those as well after this talk. So yeah, so when we face this issue again, we piggybacked on Istio to solve this. So basically, what this looks like is this is one of my pod. In my pod, I have my service container and my sidecar, right? And what how we solve this problem is, if I'm making, like I said here, we have a payment gateway, so there will be a URL for that, right? For example, say paytm.com, just an example. So if you're using Paytm, Razorpay, or some other payment provider, what we would do is we will instruct basically Istio to tell, hey, if you're seeing this host name, rather than sending it directly to NAT gateway, send it to this particular VM. So these egress proxies, these are nothing but VMs that we have created. They have public IPs, and there is no ingress traffic. There is no port, any firewall rule which will allow ingress traffic. This is purely used for egress traffic. So what happens here is Istio takes care of that additional routing or traffic management, wherein if it sees this particular host name, it matches that and it starts routing it to these target VMs. And from there, we are running Nginx with the stream module. It simply does a pass through forwarding to the target, whatever we are using. And this is so that is another example where Istio have helped us with traffic management or egress traffic. So that is three to quickly recap, right? Observability, load shedding to get out of unforeseen load issues on upstream systems, and way to have a scalable egress traffic system, right? These are the three use cases we use Istio for. There are others as well. This is the three we just wanted to touch base upon. Cool. Uh, we'll quickly look at some of the delivery related things next, right? So this metric is from last year or the previous year. We've done around 32,000 releases a year. That is like 60% releases a week, and there will be hot fixes as well. Some of them, the pace at which our dev team work sometimes is hats off to them. They might get a requirement in the morning and they're ready to ship it by evening, right? But at the same pace, at that pace when they're working, it is the platform team's responsibility to put certain measures in place so that they can peacefully go ahead and deploy the changes, right? So delivery pace we talked about, and now we need delivery piece. And sometimes issues like this used to happen in the past, wherein you go ahead and do a deployment, suddenly you'll start seeing a spike in 5xx. Our 200s will drop, all kind of messy graphs will show up, right? Now we were ideating how we could solve this problem. uh, like a straightforward answer would be canary releasing, right? Like what do you mean by canary releasing here, right? So basically we want to deploy the new version alongside the old version, and then from the ingress point, we route maybe a small percentage of traffic to the new version revision that we have deployed. And like if you're doing this manually, what would we do, right? Like if we are doing this manually, like initially when we were migrating from VMs to Kubernetes, what we had done is whatever nginx that Shri mentioned. From there we started pointing traffic or routing traffic, a small percentage of traffic, to Kubernetes. We used to monitor the metrics in Prometheus, and that is how we were doing that migration from VM world to Kubernetes world. So this does something similar. We were looking for solutions which could do that. Istio, with Istio, it's possible. Just that we need some manual things to do. Flagger automates this whole process. We have to again just specify the developer experience around it is quite easy. I just want to specify what is the target state, how should the traffic be routed to the new version, at in what steps, in how long should I wait and monitor, right? Like, okay, now send 5% of the traffic to the new version for next 5 minutes, see the metrics. It basically looks at Prometheus for this particular service. What is the 200? What is the latency? We can tell about this latency, revert back to the old version. In steps it will start taking traffic to the newer version, and once the 100% traffic is in, it does the full switch over. That's what canary releasing, and that we use Flagger for that. Flagger supports a bunch of providers. We are using Istio, so it supports Istio provider as well. So that is around the canary releasing bit. I'll take a pause. If there are any questions, uh, we could address that. And are there any questions? And if not, we can proceed.
Um, I don't see anything on the comments section. But, just one question from my side, like why not Argo CD here? Like, are you guys using any other CD tools?
Right. We'll come to that towards the tail end of this. So we don't use Argo CD, or we don't have GitOps as well today. What we have is we use this tool called GoCD. GoCD takes care of our CI/CD side of things. So we didn't want to bring in Argo CD to solve that canary releasing bit back then.
Okay, and another question on the observability part, like do you guys use any APM? Like you already mentioned Java, Node, and Golang is your stack. So
Mm, we have tried New Relic in past. We faced some issues because of which we roll back. Today we are not using any APM. Purely we have Prometheus metrics, Loki for logs. That's all we have today for observability side.
basically the Grafana stack, not even Elasticsearch.
Uh, Not Elasticsearch. We use Prometheus. We use Grafana. We use Thanos for long-term retention. We use Loki for logging.
Okay. Yeah, we got another question from one of our viewers, Shagish. So he's asking whether a rollout max search would work for deployment.
Rollout max search. Is this the deployment ka rollout strategy?
Maybe 1 second. I can bring Shagish to be a presenter. Okay. Hey Shagish, like if you want to ask the question, please unmute and you can speak.
Sir, you were telling about this bringing the canary services, right? So instead, what if we can increase this rollout strategies? With that only, we can increase that, right? So
Correct.
that all the deployments doesn't, all the pods doesn't go down when we are doing a rolling upgrade or something.
Correct. So, what would happen with the case of rollout strategy is I can tell at what percentage. I can even keep 0%. So my existing pods will stay as is, but whatever new replica set that get created and the pods that get created, there will be equal number of pods coming, right? But still, the problem is I don't have finer control on the percentage of traffic that will be going to the new pod, and potentially also what is the response code, what is the latency. I don't have control on these. That purely the deployment rollout purely works on the readiness and liveness pod. If new pods are coming up, they are in a ready state, right? Existing replica set ka numbers would get reduced, the new replica set may the number of replicas would get increased. So we don't get that finer. We have actually tuned that as well. Initially, while doing deployments, what would happen? The default I think is 25 percentage. It'll go ahead and remove 25 percentage and bring up new. So we made that 0 percentage to ensure that uh, we have surge upgrades in place. But canary releasing, it doesn't support canary releasing. For that, you need a setup like this. Did I answer your question?
Ah, yes, yes, Adarsh. Yeah, thanks.
Yeah, just to add to what others were saying, right? So in our systems, 25 percentage of the pods, if that gets degraded, there is a potential chance for the whole deployment to get degraded because the ops is that high. So, like Adesh mentioned, it will become ready. And when the request starts coming up, that is when those two pods would have potential issues. Those two pods might go down. Thereby, that 25% of the traffic will be distributed across the remaining set of pods, which can in turn bring the whole system down. And we have had multiple cases like that. Right? So, it's always better to isolate. So I'm taking 10% hit on the traffic. I'm sure 90% of the traffic won't be hit, whatever happens. I get confidence on the 10 percentage, then I'll move to 20, I'll move to 40, and so on. So Flagger also gives you that capability. That percentage is strongly signed off. Only then I'll move to the remaining set of percentage, which might be a little hard to achieve just with deployment rollout strategies.
Okay. We have another question from Jitu. So, any reasons why we didn't use circuit breaker instead of sending the error from Istio 500 arrays part? Also, can you explain a bit on external traffic routing? How you add a new external endpoint when a new app comes in?
Okay. I'll take a stab at the circuit breaker part. Shri, feel free to fill in. We have tried using Istio circuit breaker, but for some reason we couldn't make it work. One, we didn't have some clear visibility into what was happening. Some cases it was kicking in, some cases it was not kicking in. We've tried that. We've tried that in early 2020 itself, but we were not able to make it work.
Okay.
Shri, do you want to take the second question on the external traffic management part?
Like
Yeah. So,
how we add a new external endpoint when new app comes in.
so when you say, so this is with respect to that egress proxy, Jitu.
Egress proxy.
Okay, okay, fine. Can you explain a bit on external, how you add a new external endpoint when a new app comes in? Assuming by new app, so let's assume maybe I'm integrating to maybe Visa and some other payment gateways. I'm assuming when you say an external, yeah, that's okay. When you say an external app, I'm assuming it means another external integration. Okay, I'm gonna go ahead with that assumption. Uh, so like we say, if you look at this diagram, that egress proxy, right? Egress proxy could be configured to talk to one of the endpoints of our choice. So I could say that, okay, I'm talking to ABCD as well as XYZ. There are two domains that I need to talk to, two external endpoints. What we usually do is for each of those or a combination of those external parties, I'll create a cluster of egress proxies. So maybe there are three proxies running just to be on the safer side with failovers and everything. We'll have three egress proxies running. Each of those egress proxies will be in a position to route traffic to abcd or xyz.com, right? So if a new one comes in, depending on criticality load perspective, we take a choice on whether it should be added to maybe one of the existing proxies or we create a new proxy. I think we usually go ahead and create maybe domain-wise proxies, and within domain-wise proxies, we have other bifurcation, right? So there's some amount of bifurcation that happens. So these egress proxies exist. Creation of these egress proxy VMs, we have a separate automation for it. But once the proxies are created, going ahead and configuring this traffic to be routed all the way up into this egress proxy, those are all automated through ST only. All the service entries, workload entries, and destination rules and virtual services that are listed here, all of them automated. We just need to put the domain name there. with which proxy should I be using. Let's say I have egress proxy for Visa and I say visa.com, point it to egress proxy one URL. You put in that mapping, you redeploy, it will automatically get set up. And when the application makes a call to visa.com, it would get routed to one of the proxies, which is kind of a reverse proxy. It will forward it to that particular uh, 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 external party. And so that's how it works. It's if we need to have more and more proxy servers, we need to run a separate automation to set up those proxy servers. Adding more and more external third parties into existing proxy servers is just a you know code mapping. You need to put a mapping in a code file and then redeploy certain things. And I'm hoping that's what you wanted to start.
Yep. Thank you. Finally, I was able to find the unmute thing. By the way, what you said, I believe like the internal traffic, like how you distinguish between the external domain DNS flow as well as the internal service calls, like say within the cluster service A calls service B, and both of the services are calling a third party as well. So how you tell the Istio proxy that service communication should be internal and some external domain should be through the egress proxy? Like you just eliminate creation of service entries for those, or let the Istio handle it by themselves?
Yeah, for the internal services, we don't create service entries. Uh, because the external parties are not part of the mesh, we make them part of the mesh by creating service entries for these external guys only.
Okay, I hope that answers your question, Jitu.
Yep. Thank you.
All right, maybe we will take one more question, like one last question, like from the comments. So, since your microservices are built using different programming languages, how do you handle graceful shutdown in Kubernetes? Are we using any libraries or techniques to ensure a seamless and reliable shutdown process?
Cool. So what we have is we have just three languages in place, and which is Node, Golang, and Java. And we have written again, like I said, we have Rapido. There is one more tool that we use for build and deployment CI/CD side of things, right? Internally, that was created called Hermes. We'll look at the text that tech stack we are using in that. As part of that, we also do scaffolding. So any new service that have to be onboarded, we generate the scaffolding for that. As part of that scaffolding, all this graceful shutdown, etc., is taken care. We don't have a library, but it's part of our scaffolding.
Okay. So for this scaffolding, I believe you might be using something like Backstage or something.
We don't have backstage like that's a CLI tool again. It
Okay.
I think it's back. It is backed by GitHub templates. It just take a template repo and generate the code for us.
Okay, cool.
Cool. Then I think we'll continue.
Yeah.
And yeah, like always, whenever there is a problem, like we say, it's always DNS. We've had our great share of issues with DNS as well. So one thing about DNS, especially in Kubernetes, when you are using kubedns, is how kubedns auto scale. Um, GK have there is basically this is something we were not aware of then. Like while we jumped into the target state and Kubernetes with enough deliberation, we have faced a lot of problems because of again the scale at which we are working. We keep telling scale, right? Just to take some numbers, I think early 2020 we were doing somewhere around 2 lakh orders a day. Today we do somewhere around 3.4 million orders a day, and that's the growth that we've had with the infra that was defined or designed back then. Um so the problems that we have faced is, one is auto scaling kube DNS itself, right? So there is this config map in which you can tell for how many number of pods or how many number of cores, how many kube DNS pod you should run. Should always find a right balance there. Again, you could go with crazy numbers, but the problem is it's a trade-off of cost. You will be running too many kube DNS pods now, uh, and they are going to come and sit in your nodes. Problem you would face with that is cluster autoscaler wouldn't target those nodes for scale down. So there will be nodes running where just kube DNS pods are running. And sometimes it's very tricky to set a affinity or etc. on this kube DNS. You can have taints and tolerations, but that is one thing to keep an eye out for. So basically configuring the autoscaler for kube DNS. Now, after again, one other issue that we faced from in production is one of our high RPS Node.js service started getting timeouts, basically. Started returning response code 0 that spiked up. With this weird error, e timeout, EA again. And this is when we had tried New Relic, and we had New Relic integrated to some of the services. From New Relic, one thing that we noticed is it's the DNS resolution time that is spiking up. So basically, DNS resolutions are taking time, because of which we are getting timeouts in Kubernetes, services running in Kubernetes, right? So started debugging, started looking into things, and just want to, before we go, want to talk about this resolve.conf file. It will be there in almost all our Linux based systems. And in that, these three things, right? The first part is search. This I've taken from one of the pod, right? So we have, it has something called a search list. Basically, unless you give a fully qualified name, it basically goes through whatever I'm trying to resolve. Let's say I have a order service, right? If I'm trying to call that, it will look for this option called n dots. Here by default, Kubernetes n dots is set to 5. So unless there is 5 dots in my domain name, that, or the host name that I'm trying to resolve, or it's a fully qualified domain name, what it would do is it will keep adding whatever search list that we have, which is this set of lists that we have. Again, I've cut short this. There were a couple of others as well. I've just reduced it to fit it on the screen. It'll keep taking this and appending it to the whatever domain name I'm trying to resolve, and it will keep sending it to kubedns. The problem with this is there will be a bunch of resolution calls that goes, which will definitely return nx domain, because none of them exist. So one thing that we had played around with is reducing the end dots. We initially made it 4, we then made it 3, and then finally we switched to 1. So how do you do this is, in your deployment for the pod spec, you can specify what is the DNS config, and the options you can mention the same options that we saw previously here, and on set to 1. So as long as there is one dot uh, in the in the host name, it'll go and resolve it for us, right? And we keep using fully qualified name everywhere else, so this was never a problem for us. This is some screenshot from non-prod. This time is when our regression suits run, and around that time we tried switching to n dots of 1. You can see the number of errors, the number of even the number of requests that we are getting in kubedns, it dropped substantially. So that is visible here. And similarly, the next thing after this is, it worked fine. This worked fine for some time, but like I said, the growth was in a very exponential way, wherein somewhere around 8 lakh orders, when we were doing a day, 10 lakh orders a day, we again started facing issues with DNS. So we had, by this time, we had set up alerts, which is if the P99 latency on kube DNS is going above, say 100 milliseconds, we should get an alert. So we have set up alert. We started seeing this alert. So debugging is easy. So one thing is, whenever we find something, we always make it a point that we set up the alert so that next time you don't have to spend that amount of time to debug and figure out where this is happening, why this is happening, etc. Right? Again, we started seeing these alerts during peak times. We started looking at other options, and we came across Node Local DNS Cache. What Node Local DNS Cache basically does is it runs as a daemon set. So on every host, there will be one pod running, which will cache all the DNS resolution calls response that we are getting from Cube DNS, and it basically plays around with IP tables. And whenever a client makes a call, instead of that call going to the Cube DNS, it is try to first resolve that or try to answer that from the local DNS cache. If not, it forwards to the central Cube DNS pods. And this is the graphs before we started rolling out Node Local Cache. And if you see here, we were doing on Cube DNS somewhere around 2.5 hits and somewhere around similar misses as well, right? And there were errors and other things you can see all together. This is metrics of Cube DNS. After rolling out, again, next day around the same time while the regression suite is running, we checked the number of requests went to less than 30. So now the cache has started respond, like the cache hits were there, because of which the load on kubedns reduced substantially. So that is one other like again what tradition in with the traditional setup, right? If we have to solve some of these problems, it would be quite difficult to set up something like this and make all of this work, right? With Kubernetes, it's a seamless experience. It's there, it's an add-on. We have to just go and enable something, and it's there, right? That's what Kubernetes have helped us with, be it ndots, be it if we are in a VM world, we have to apply that on multiple places. With this, it is just go ahead and just update that and do a restart of all the pods. And that where we have many scenarios where we have to restart all the services. For example, we initially had multiple services depending on one central database. We have taken that out. We have taken that God DB out today. It's not present anymore because it doesn't scale. But whenever we are doing an operation on that, because some clients were not resilient to database restarts, we had to restart all the services. It's just a command away. Just use the list of either use a label or something and just trigger a rollout restart. You can rollout restart all the services, right? So that is one other area where it have helped us. And finally, to talk about the tech landscape that we have at Rapido, right? So we talked about Kubernetes, we talked about Istio, we use Cert Manager for managing SSL certificates, we talked about Flagger, we use Helm. So configuration was a problem that Shri mentioned. We use Console and Vault for handling that. Prometheus, Thanos, Loki, Grafana, we answered that as part of Vishnu's question. Another thing we use is external DNS. So previously we have this divide layer. So we use Terraform. So if we deploy a new ingress, and now we have to go do the DNS mapping. We use Cloud DNS separately on Terraform. Now again, if I'm creating a ingress object, if somehow magically the domain mapping also could happen, it would be very nice. So external DNS helps us with that. What it basically does is it looks at service object, it looks at uh, ingress objects, and it basically go ahead and add the DNS entry for us. So that is on a high level what our setup would look like. Shri.
Yep. Yeah, I mean, so the journey was good. I think over the last 5 years, I think most of us in Rapido have learned one or the other thing about scale. So this is just a representation of a current state, right? So from a scale perspective, 50 million requests per minute, um, tons of events that gets produced to multiple Kafka clusters, like around I don't know, somewhere between 10 to 20 database clusters, maybe similar number of Redis clusters, different variants of database clusters, including Mongo, including Elasticsearch, Cassandra. We also have Postgres and MySQL, uh, all supporting or handling the scale in one or the other way. The scale has only grown and grown every day, and it's growing. I mean, I don't think the scale that we see today will be the scale that we see tomorrow, which kind of creates more and more challenges, right? You can just show the next slide also, Adarsh. Um, so yeah, so that this is just a overview onto the business side of things. Like we do 3.6 million plus orders per day. To do 3.6 million, we need to have a lot more gross orders. So that kind of represents the scale. 2,000 odd rides per minute, and so many captains who kind of make a living out of Rapido. Uh, Bunch of other things that we have achieved over the course of last 10 years, right? Like we were saying, I think scale is going to increase, and we realized that uh, we always assumed or thought that okay, there's going to be a gradual increase, it's going to be organic, and it's going to be a slow curve of increase. But then that has kind of changed. It's not like day to day. Yes, there is a small increase, but then what we thought okay would happen in 6 months is kind of now happening in 1 month. Right. So one thing that we are very happy about is uh, many of these toolings that we've chosen has made our ammunition much loaded. Right? Like knowingly or unknowingly, we have a lot of levers in place. Like Adarsh was saying, the fault injection. I don't think any of us thought, okay, that would become one of our primary recovery levers under problems. No one would have anticipated. I mean, our ideal world would have been, oh, we will never have an issue like that in production. But trust, from our experience, I think an ideal world is very hard to achieve. So you will need to have measures in place to come out of this, and for that you need to have a heavily loaded ammunition with you. Many of these toolings kind of have that. We will potentially figure it out on the way, because when that real scale hits, that's when some of these non-trivial problems comes in. And then when we run around, we might stumble across something and we'll be like, wow, that's pretty cool, right? So from that perspective, the many of these technologies have helped us a lot in reaching this position through automation, through achieving resiliency, through achieving scalability. um, that's something that we're happy about. Hopefully it will survive, and maybe we will figure out more such toolings on the way. Yeah, I think this is what we wanted to.
Cool. Also, we are hiring. So if you are looking out for a job change, do reach out to us,
Yeah, cool. We have few questions if you can take that up.
please.
Yeah, one from Manoj, like how did you reach a point where your developers are able to ship features so quickly? How do you give them a environment which all these various infra pieces, and how we control cost?
Okay, so that's a multi-part question. Where do I see the question?
Yeah, that's in the chat. It's on the right hand side of your window.
Yeah. How do you reach a point where your developers are able to ship features so quickly, right? So primarily it is CI/CD, right? Like we use Git flow. People can deploy in on-prod and get some kind of sanity, and they can get some confidence there. Moreover, that we have this whole setup of tools where in our test run as part of CI pipelines, we get some guarantee with that. After all this, end of the day, it goes through the canary release flow, wherein if at all something goes wrong, we have a safety net there. It is basically that safety net and the pace at which, again, a lot of it goes to the developer pace itself. A lot of them pick things up and delivers things out, ship things out. Like I was telling, they might get a requirement in the morning, by afternoon they're ready to ship. So a lot of it is on them itself, and there is some of the safety net that we have put in place, which gives them that confidence. There was a second part to that, right? How do you give them environment with all those various infra pieces? And okay, so We have three environments: production, staging, and dev environment. Primarily, it is staging where all the sign-offs happen. Dev environment is where people are ideally supposed to deploy and test, get an initial feel of things are working. But these are the three environments that we have. And control cost. So in non-prod environment, we use Keyboardno, another tool which again cloud native tool that we are using. So what we do is unless explicitly allowed, the resource request, the HPA, min replica, max replica, etc. is kind of capped. So that is how we control cost in non-prod environment. Sri, do you want to add anything on that? The
He's right. That mute button is quite fancy. There's that preferences which keeps coming, which keeps opening up. Yeah, I mean, not anything specific, but just to call out. I think we have made the environments as similar as possible, not from a size perspective. If that service is calling another service and is able to get a response and is able to react to it, I think from that perspective, like the application deployed in staging as well as deployed in production is exactly the same, right? Yeah, I mean, versions are different, but how that interactions happens and everything, we kept it very similar. Underlying infra, the size of the infra could be different. Maybe some clusters are shared and everything in staging. That's how maybe cost is controlled. But from the application functioning perspective, it's exactly the same across all three. So if it's going to work in staging, bar the scale, it's going to work in production. So that's the confidence that developers have. I can answer the next one also. If chaos engineering red team. So yeah, I mean, we don't use any tools to do this. Okay, we will sooner than later. But we do a lot of these resiliency testing. Again, maybe using Istio, we inject falls, we inject delays. While automation is running, we kind of inject delays to ensure some of the critical scenarios are not failing. When there are sign-offs that are happening related to stories on critical areas changes, we do kind of bring non-critical services and ensure the vanilla flow is running. So there's always emphasis on ensuring the vanilla flow is always up and running, right? I mean, to get a user to go through a journey, you don't need all features that is potentially existing in Rapido to work. If it all works, yes, the user will go through a very richer experience. But then under stress, we don't want to be like, okay, I want the richest experience or else I don't want to have any experience. No. So we also always have layers of failures, right? So that kind of testing happens. There are every like we have a critical funnel flow. In that we have so there's a vanilla flow out of which it gets enriched through different interactions to non-critical flows and everything. So there we inject fault, inject delays, do some amount of load and then try to test. If these services which are non-critical in nature for the vanilla flow, if those are degraded, how would our system behave, right? So there's some amount of testing. It's not automated today, it's kind of manual. I think while we speak, we are also in a discussion to figure out how do we make it a repeated exercise, have that safety net as part of every release cycle to ensure that no new interactions are being made, which has become critical even though it's a non-critical feature, right? So those kind of things does not come into existence. We're kind of figuring out how to potentially automate it.
Okay. So the next question, how, like, also what are the security measures you take to ensure in your tech stack? I think we haven't covered much about the security tooling that we have.
So one primary thing that we have is network level security. So I'll start with that. We don't have public IPs, or most of the systems are private unless you are on VPN and you have the system you can't reach in. Now, other things like supply chain security, another thing, we have a internal security team. Um, we do internal security audits as well on mobile and backend applications, the things that we are expecting via API gateway. So all of that happens. Also, we use a third-party tool which kind of looks at our cloud posture and gives some kind of information. Let's say if somebody opens up a port accidentally, that system flags it and it gives us a basically a alert.
Okay.
That's not a open source tool. That's a paid tool that we are using.
Okay. All right. And another question: how do you handle access to the backend? Do you use any tools like a teleport? I think probably how we do shell access.
Did you want to take that or should I?
I can say we don't use the report. We
Yeah.
use something called Pomerium, but you can give more just on it.
Yeah, so again, the solution there is we use Pomerium. We use the open source version of Pomerium, wherein all accesses go via. We have Pomerium and have Keycloak for. Pomerium is an identity aware proxy. We use Keycloak for authorization side of things. So it all ties back to our single sign on end of the day, right? And we give roles and access in Keycloak. All of that is driven by a Git repo that we have created, and we have an internal tooling called Heimdall, uh, which takes care of syncing the state from that Git repo to Keycloak. Shri is a huge Greek god fan. That's why a lot of our tools are having Greek god names.
Okay. That's good.
Shell access is a no. Like we don't provide shell access to VMs for the
Yeah.
for a lot of people. Like maybe a very minimal subset of people have shell access. kubectl again is through Pomerium.
Okay.
kubectl gets authentic, and you will the access that you need. Like if you want edit access, it's controlled via key clock through Pomerium. Again, linked to our Google email IDs and all. So based on that access, kubectl request also as a proxy through Pomerium, where the authorization check is done to ensure you have the right access to execute it.
Okay. Got it.
We missed one that QA question. I'll answer that app and prod during Canary release. So that does not happen that way. So this Canary release is for backend deployments, which are like service deployments. So what happens is all our services gets deployed, which will all be backward compatible, like which will be in a position to work with V plus one, V next version and the current version. All services gets deployed, and then the app goes live. And app also goes through an adoption, right? None of us like immediately update the app. But we also have a rollout strategy on the app perspective. There's a beta set of users to whom we roll out, analyze crashes, look at performance and everything from an app perspective. We have two apps, Captain app and a customer app. Both of them goes through beta users, and then that is also rolled out in stages. Like the Canary release that we talked about, like which is using Flagger, is for backend service microservice deployments, which is just when I'm deploying that service, I ensure that service is healthy and it is able to work as we expect it to work, and it's not buggy or it's degraded from a performance standpoint. Right, and all these deployments are backward compatible. It will work with the previous version of the app as well as the previous whatever versions we support. It works with all those versions of the app and the next version of the app also.
Okay, another question is like since you are using open source Loki and Grafana for log monitoring, do you face any challenges there like while loading a huge amount of logs? Any issues while scaling, like spike in logs or you know?
Yeah, we have. So okay, to give some background, we initially had uh, Kafka, Fluentbit, Elasticsearch, Logstash based setup. Operationally, it was a pain in the trash, right? Later, we went to Loki. We started with Loki 2. It made that life easier and it worked fine. But over time, along with this increase in orders, number of pods increased, number of nodes increased, number of log lines increased, and we had literally developers having a very bad experience with Loki. This has happened for some time. We started looking at options. We did some tuning on Loki. which gave some short-term breather, but again it reached a even worse state. We upgraded to Loki 3, and the experience after that is tremendous because Loki 3 have they have changed the index that they are using internally, right? They have switched to TSDB based index from BallDB. That is one thing. Plus, they have Bloom filter and a bunch of other performance optimizations that they have done with the metadata service, etc. We have had a detailed discussion about this in Grafana and Kuchi sometime back. Uh, so there was a talk that we had done there on how we were scaling Loki at Rapido.
Okay, I assume like migrating to Logi 3
Loki 3, yes.
made the life so easier.
Yes. If you
Okay,
blindly go, like you can trust us blindly go and upgrade to Loki 3, it will be much faster.
okay, that's a good advice. Cool. And one other. Uh, okay,
Which
so
version of Loki are you? If you are on 2x, switch to 3x. And if you are not running microservices mode, switch to microservices mode.
okay. One other question for me, like currently I am assuming that you guys will on ingresses, right? So we will need to move to API, the gateway API, right? So have you tested that in your environment? Any feedbacks that you can share now?
We haven't tested Gateway API. Like we've been playing around with personally, but we haven't tested. But Ingress wouldn't go away soon, is what I remember. Gateway
Mm,
API would definitely
take over.
come take over, but Ingress is not going away anytime soon.
Yeah, it will be there. Yeah. Okay. So I think there are no more questions coming in our chat box. So, okay, another one. What type of scaling strategy with respect to the K8's deployment?
Horizontal scaling, you mean if
Horizontal mostly, right?
Hmm.
I guess the question was that. Yeah, yes, yes, yeah.
okay. Yeah, we use HPA, Kubernetes HPA.
Mm.
One other additional thing that we do is we use Prometheus adapter and lag-based Kafka lag-based auto scaling. That's one other thing we do.
So for Kafka, maybe you guys will be using StreamC or is it just
For running Kafka, we are running on VMs, not in Kubernetes.
oh okay, that's like have you did some benchmarking on Kubernetes and switch it back to VM or
It was always in VMs. Uh, we don't have consensus among ourselves yet to move databases to Kubernetes.
Kubernetes?
Yeah.
It's too
Because
too big a scale for us to even think of running it in Kubernetes or Kafka cluster. I mean, even if you run it, it's going to be one pod per node. So,
okay,
I don't know how much of a benefit it's going to give us. Yeah, but maybe there are people who are running it, but for our scale, we just never got the confidence.
okay,
Uh,
so it's like a virtualization on top of virtualization, which add more latency. That
Correct. And yeah, everyone who needs to be in close access to this network and disk and everything, putting layers on top of it is going to give us more and more trouble, which are going to be more harder to potentially understand. So maybe we are okay, fine. This is not a battle we want to choose now. Maybe later. For now, let's just keep it up and running and stable.
okay, cool. So there's one more question. Maybe let's just take that question and wind up our today's session. So this one, have you tried KDAS scaling based on Istio request count?
Not on Istio request count. I like that last question.
Yeah,
Take that as well.
yeah, sure.
So we never tried KEDA for Istio request count, but we did KEDA for the Kafka lag based thing. We tried it out, but our only use case then was just with Prometheus, just with Kafka lag based service with the Prometheus adapter based approach. If we are doing that today, we'll definitely would have gone with KEDA.
Okay.
Our
So
DevOps team is 4 people strong.
for people like including SRE responsibilities. Is just four people, you mean?
So SRE, we don't have SREs. Developers take care of a lot of that.
Okay, on call activities.
Yeah, the core platform team which handles this is for member team.
Oh, that's great.
We are hiring for more people again.
Yeah. Okay. So how people can reach out to apply?
You can reach out to either of us on LinkedIn.
Okay. Cool. So guys, we'll be tagging Adarsh and Sreerajan in our post, in LinkedIn post. Please reach out to them if you guys are interested in joining Rapido. Okay. Sadish is asking another question. Like, how you manage the Istio upgrade?
Istio upgrade is a we don't do that blue green deployment or anything. If in place upgrade we do, and often we falls a long way behind, and we have to jump multiple versions. So if you want to do a zero downtime upgrade, you'll have to do multiple versions. But what we end up doing is we take a short downtime during late night hours with the business approval, and we jump the multiple versions after signing it off in non-prod environment.
Okay. Cool. So I think let's conclude with that question. So again, once again, Adarsh and Sreerajan, thanks for your time today and coming prepared for this session with all the slides and all this information that you shared. I think it is wonderful. If everyone keep doing this, I think we'll get a lot of knowledge. I mean, the experience that you guys shared about using um, even about the Logi, like from migrating from Logi 2 to Logi 3, that kind of information is really uh, knowledgeful, and that is something that we are expecting in this community. People come forward and share this type of experience, and yeah, that's really amazing, guys. Thanks, Adarsh and Sriraj. And guys, everyone, please follow us on LinkedIn. Iqbal have already shared the link for our page. We'll be tagging, like we'll be uploading the session in our YouTube channel, and we'll be posting that in our LinkedIn page. And please reach out to others and Sriraj if you guys are interested to work on this amazing cloud native tools and technologies that they use at Rapido. And these guys really are amazing. I mean, from this session, I have talked to others on call multiple times, and the way he explained things or the way he have shown interest in taking sessions and everything is really commendable. So please reach out to others or Sridaj, like if you guys are looking for some amazing opportunities. And guys, others and Sridaj, thanks for this amazing session. And thanks to all of you, those who have joined this session. Thank you.
Thank you.
Thank you. Thanks, all.